These are the Algebra 2 section 4.9 video notes. So we are starting with example 1, which says write the cubic function whose graph is shown. All right, so if we look at this graph, from the graph we can tell the x-intercepts. So the x-intercepts are -4, 1, and 3. All right, so our x-intercepts can give us our factors. Remember that if we go ahead and we have x minus the 0, that creates a factor. So if we do x minus -4, and then x minus 1, and x minus 3, those create the factors. I'm going to go ahead and change minus and -4 to plus. All right, so this is my equation, and I have f of x equals, and then I don't know the a value. The a value is that stretch or shrink and reflection that controls the shape. So I start with step 1 is write out my factors. All right, step 2 is use a second point to plug in for x and for f of x. So use another point, any other point, plug in for x and f of x, which remember x and f of x is just y. So at this point here, this 0, -6, it happens to be a y-intercept, but it doesn't have to be, okay? It could be any other point. And so you plug in the -6 for f of x, because that's the same as y. You don't know a. You plug in 0 everywhere there is an x. So in all x values, you plug in 0 because of that point. All right. So then I go ahead and in my calculator, I'm going to plug this in right here. I'm typing that in my calculator. So I find out that that ends up being 12. So it's a times 12, or 12a. Now I divide by 12 because I'm trying to solve for a. And I end up with -1/2. So that's my a value. So now I can write my function. F of x equals, my a value is -1/2 times x plus 4 times x minus 1 times x minus 3. And that function would give us the graph that is shown to the right. All right, so if we try this again, keep in mind that these points here with 0 and the y value, these are your x-intercepts. So these make your factors. So we're going to have f of x equals a times, and you do x minus -4. That turns into +4. You do x minus 2 and x minus 5. That's step 1, is to create your factors from your x-intercepts. Step 2 is to take a different point than your x-intercepts and plug that in for x and y. So this point they give you, once again, it happens to be a y-intercept, but it can be any point. It doesn't have to be a y-intercept. So I plug in 10 for y, which is f of x, and I plug in 0 for x. I'm going to put this in my calculator right here, and I end up with 40. So it's 10 equals a times 40 is 40a, and then divide by 40 on both sides. So I end up with a is 1/4. So now I can write my function. It's f of x equals 1/4 is a, and then it was x plus 4, x minus 2, x minus 5. All right, now we're going back to example 2. It says use finite differences to determine the degree of the polynomial function that fits the data. So how you use finite differences is you take the data, and they have to go in like a pattern with the x values going like 1, 2, 3, 4, 5, or going by twos. They have to be evenly spaced x values. So we have that, and then what we do is we take the y values, and you're going to take the right y value, which is 4, minus the y value just before it, which is 1. So 4 minus 1 is 3. And then you'll do 10 minus 4, the right one minus the one just before it, that's 6. 20 minus 10 is 10. 35 minus 20 is 15. 56 minus 35 is 21. And 84 minus 56 is 28. So that's the order you do. So I kind of wrote them out right here so you can kind of see my order. So I take the right number minus the number just before it. Okay, so now you do the same thing with these numbers. So you're waiting to see until they are all the same. You're looking for common differences. So now I'm going to do 6 minus 3. So I get 3. I'm going to do 10 minus 6. I get 4. I'm going to do 15 minus 10. That's 5. 21 minus 15 is 6. 28 minus 21 is 7. So I do it again. When I do 4 minus 3, I get 1. 5 minus 4, I get 1. 6 minus 5, I get 1. And 7 minus 6, I get 1. So notice that on row 3, they are constant, meaning the same. All right, so what that tells you is it tells you it has a degree of 3. So if they were constant on row 2, the second time we did it, they would have a degree of 2. They're constant on row 4, they'd have a degree of 4. So since it was on row 3, they have a degree of 3, which means that it is cubic. All right, so we're going to grab our graphing calculator for this part, and we're going to go and we're going to run cubic regression. Now, we've done this before with other types. So you go to Stat, you hit Enter on Edit. If there's data in your list, you go up to where the black box is on L2, and you hit Clear, Enter. And then you go up to where the black box is on L1, like this, so it's selected, and you hit Clear, Enter. Now you type your data in. Your X values, 1, 2, 3, so on to 7, go in list 1. And then your Y values go in list 2. All right. From there, you press Stat, you go over to Calc. If it's a degree of 1, use linear regression. If it's a degree of 2, you do quadratic regression. 3, which is what we have, is cubic regression, that's number 6, and 4 is quartic regression. So we're going to do 6 because it's a degree of 3. So you can either go down to 6 and press Enter, or you can just press 6. So it says X is L1, Y is L2. Just go down to Calculate and hit Enter. All right, here's our equation, which we have this 0.1666 repeating, 0.5 is B, and 0.3 repeating C, and D is 0. Here's the format right here that we plug those into. And our R squared value is 1, which means it's a perfect fit. So one thing I can do with that 0.16 repeating is I can type in that, and then I can hit Math and Fraction. It says change my answer to a fraction, hit Enter. And this one might not do it. If we do enough of the repeating decimals, see if I can get it to do it, it should change it, and so you know that that is 1/6. So the A value was 1/6. The B value was 0.5, which is 1/2. The C value was 0.3 repeating, which is 1/3. And the D value was 0. And then, of course, it told us that it was ax cubed plus bx squared plus cx plus d. So if we fill that in, we're going to find out that our function is 1/6 is a, so that's x cubed. B is 1/2, so that's 1/2 x squared. C is 1/3, so that's 1/3 x. And D is 0, so I don't have to write it. And that is my equation. Okay, in example 3, it says the data shows the numbers of bald eagle nests counted in Ohio T years after 2000. Find a model for the data. Use that model to estimate the number of bald eagle nests in 2015. So the first thing we need to do is we need to actually graph our data to see what this looks like. So if we go in here and we type in, same place where we had been, Stat, Enter on Edit. To clear your list, you go up to L1, you hit Clear Enter. Go up to L2, you hit Clear Enter. And then you're going to type in the whole list. That second row on that list was 7, 8, 9, and so on. That is still part of the same list. They just wrapped it to another row due to space. So all of list 1 are the T values. all of list 2 are the x values. I'm going to pause while I finish typing these in. Okay, so I have my values listed out, so let's go ahead and let's go to graph it. So you go to y equals. Now I need to turn the stat plot on. It's this plot 1 up here. I'm going to go up to plot 1, so it's flashing on it, and hit enter. That turns it on. Now I'm going to hit graph. Now the reason we don't see anything is because our numbers are too large. So you can either change the window by hand, or you can press zoom. And then if you go down to the 9th one, it says zoom stat. It's going to zoom in on what you put in your list. So hit enter on 9 or just press 9. And then you can see the shape. So this looks to me like it could be cubic, but it could also be, it could be quartic if it had like kind of that upside down M shape kind of. So it could be either. So here's how we find out. We go back to stat. We go over to calc. We go get down to cubic regression. Let's try cubic first. So we hit enter, tell it to calculate. Now, this r squared value is 0.9568. So kind of jot that down or keep that in your mind. It's 0.9568. So let's do this again. Go to stat, go over to calc. This time let's try the quartic regression because I'm not sure which one it is. Hit enter on it. Go down to calculate. And let's see, we're going to have to scroll down to see its r squared value. Its r squared value is 0.987. So that has a better r squared value. What that tells me, since that r squared value is that it is quartic. And that's how I can tell between the two if it's too close to tell. So you can see the format here. It says it's ax to the 4th. So a is like 0.0202. You could probably just round it off. I didn't necessarily say what to, so I'm just going to call it 0.02. So it's f of x equals 0.02 x to the 4th. Now look again for your b value. B is minus 0.73, and that's x cubed. Look at your c value. C was 7.79. It was positive, so it's plus 7.79x squared. All right, D is minus 11.03, and that would be with x. And then E was plus 69.71. And that would be our equation for this. Now, if this is T years after 2000, then to find 2015, we want to plug in 15 because that would be 15 years after 2015, which you would then just use your calculator and plug in 15 using that equation. All right, so if I did that, I would have times 15 to the 4th minus 0.73 times 15, sorry. Third, and then it was plus 7.79 times 15 squared, and it was minus 11.03 times 15 plus 69.71. And so roughly 206 bald eagles or bald eagle nests in 2015. But hopefully on your homework will tell you what to round to. If you want to, pause the video and use finite differences to go ahead and find what the degree would be on this one. And then I'll show you the answer. You can use your calculator to calculate the equation once you know the degree. All right, remember I subtract the right number from the left. So I did 15 minus 6, and then 22 minus 15, and then 21 minus 22, and so on. They were constant on row 3. That tells me it's a degree of 3, which is a cubic. I plugged this into my calculator, and I ran cubic regression, and that's how I got my solution.